All right, this is 11-3, the cross product of two vectors, video 1. Please go ahead and fill in your notes as I talk about these things. The cross product is just another way to multiply two vectors. We did learn the dot product. The cross product is just another way. I know, who knew? Two ways to multiply vectors, weird. So here we have two vectors in space. I'm just defining them using the unit vectors I, j, and k. All right, the cross product is just this formula. Okay, so this is a matrix, which we will talk about in semester 2. But this little formula will help you just find the pieces. So I just write I, j, and k along the matrix, and then I write the first vector and the second vector. And then it's just like U1, U2, U3. We've talked about those components, and same with V. And this is just how to multiply them. So U2 times V3 minus U3 times V2, that difference will give me the cross product's new I part for that vector, the first component. I'll show you another strategy that's easier to remember, but this formula also works. Okay, then you subtract the J1 and it has these components, and then you add the K1, which is these components. Okay, and I'll show you how to do it. Maybe not using this formula, but an even easier way. But that is the definition. Cross products can be used to find different things. So the first thing is it can be used to find a vector in space that is orthogonal to two given vectors. So if I'm given two vectors, maybe on a plane, I can find one that's off the plane in 3 dimensions that's orthogonal to those two. I can also use it to find the area of a parallelogram if I know the vertices. So instead of using geometry, I could use some vectors. And really, I'm just going to find the magnitude, okay, using the cross product. And I can also use it to find the area of a triangle given the vertices. And it's going to be similar to the parallelogram, but I'm going to cut it in half because a triangle is half a parallelogram. And then finally, it's to find the volume of a parallelepiped, which is just a 3-dimensional parallelogram. Okay, so you can pause the video and write these into your notes. But I'm going to go on to example 1. So example 1 is just do the cross product of U and V, okay, and then show that it is orthogonal to both U and V. All right, so I'm not going to use that little formula up here. I'm going to use a different method. Let me grab from the right way. Okay, so the first thing I'm going to do is I'm going to rewrite U and V into this matrix form. So U cross V. Across the top, I'm going to write I, j, k. And then I'm just going to write the first vector in order 2, 3, negative 4. And then the second vector, negative 1, 5, 0. Okay. Now, if you want to follow the formula, you just need to know what these are called, and you can just plug them in, and that's fine. What I like to do, and if you take higher mathematics or physics, we're going to augment the matrix. Or actually, if you're going to stay in trig for next semester, you're going to do the same. So I'm just going to rewrite this column next to the matrix, and I'm going to do the same thing with the J column. Okay. And now what I'm going to do is I'm just going to multiply diagonals, and that will give me all of these things. Because if you notice, it's like U1, V2, V1, U2, they're diagonal from each other. U1, V3, if I ignored the middle column. So this is just a way to do it easier. Okay, so I'm going to start with this one. I'm going to do the I right here. So I'm going to do all of these. So this one is I times 3 times 0. So I get 0 in the I direction. And then I'm going to multiply these, j times negative 4 times negative 1. Oh, hi. There, is that better? You can see it now. J times negative 4 times negative 1 is just 4j. And then k times 2 times 5 is just 10k. And then I'm going to do it in the opposite direction, those diagonals. So I'm going to go this way. Okay, so I'm going to start with this one. Negative 1 times 3 times k is negative 3k. 5 times negative 4 times I is negative 20i. And then 0 times 2 times j is 0j. Okay, now I'm going to subtract these. Okay, you'll see some subtraction in my little formula, but this is just something we'll talk about next semester. When you do this, these diagonals are positive. When you do the other diagonals, they're the opposite sign. Okay, so now all I'm going to do is just combine all the like terms, these like vectors. So 0i minus negative 20i is 20i. Okay. J, 4j minus no j is 4j. And then 10k minus negative 3k is 13k. Okay, you probably like this form, 24, 13. Okay, so there, that is the cross product. That is just the easy way to do it. The problem also does say show that they are orthogonal to both u and v, so that's where I'm just going to use the dot product. Okay. So I'm going to dot u and v with this vector. Okay. Let's just call this vector, I don't know, w. So I'm going to do u dot w and v dot w. And what I want is to get a 0, because then they'll be orthogonal. So let me speed it up a little. All right, u dot w, 2 times 20, 40. 3 times 4, 12. Negative 4 times 13, 52. And it's negative, so yeah, that equals 0. So u and w are orthogonal. All right, same thing with v and w. Negative 1 times 20. 5 times 4. 0 times whatever. Okay, yep, it's 0 as well. So the dot product being 0 for both of these show that this new vector is orthogonal to the first two. So that was the first thing that I said what cross products can be used to do. And there you go. There's example 1.